for temperature at the core, and given that H, convective heat transfer coefficient, is 25. Okay. So we have some couple boundary conditions we can set for. So at R is equal to 0, so that is at this very center point, dt over dr is equal to 0. And since from the previous one we have this handy dandy equation plus C1 R plus C2. I should note that this is T, the function of R, radius. And we know this is 0 because at the center point, it is the main axis of symmetry. At that point, the temperature doesn't really change. So if you plug in 0 into this equation, actually, this is just TR, and we know that dt dr is equal to R squared. Okay. Neg E gen 2k R plus C1. C1 over R. Okay. So if you plug 0 for the place of R on this equation, we'll have 0 plus C1 over R, and then since R is equal to 0, is C1 over 0, and for this to be a 0, C1 also has to be 0. So we know C1 is equal to 0. And this makes this equation, if we plug it over here, this handed in the equation becomes 4k R squared plus C2, as C1 became 0. Now, at R is equal to 5 millimeter, so this is at the very outer surface, and we know at this point the heat flux actually doesn't even need to be flux. So the rate of heat transfer through conduction conduction and convection are same, making this Q heat flux of conduction and convection also the same, as we can just divide this heat transfer with the surface area, which will give us this heat flux. Heat transfer rate divided by surface area is equal to heat flux. And conduction, it is negative K dt over dx. In this case, it's going to be dr actually. Then the convection is going to be H T surface minus T infinity. And since we're looking at when R is equal to 5 millimeter, we're going to call this a big R, the maximum radius. And then the surface it is dr when radius is equal to infinity. And using this formula, so we know the temperature radius, the big R, when radius is 5 millimeter, just bring it in. So negative E gen over 4K R squared, so we're going to be big R squared minus T infinity left side remains the same. And what we're trying to do here is to solve, actually, oops, I made a mistake. And then I forgot the C2, so plus C2 minus T infinity. And we're trying to solve for C2. And we're going to rearrange it. So H moves over here, negative KH, dt over dr. And then the remainder goes over here. Actually, I'll write it out. Negative E gen 4K R squared plus C2 negative T infinity. Move everything move C2 to the left, everything else to the right. So C2, actually I'll do it the other way. So negative KH dt over dr plus T infinity plus E gen 4K R squared is equal to C2. And what we also can do is we actually know dt over dr, which is negative E gen R over 2K plus C1 over R. So what I can C2, let's move it over top. So C2 is equal to negative K over H times negative E gen 2K R plus C1 over R plus T infinity plus E gen over 4K R squared. And we know that C1 over R, since C1 is just 0, we can get rid of it. So we have this. I'm gonna make it a little more simple. So we have this E gen over 2K going on. So I'm gonna actually pull that out. So E gen over 2K, and this small r should be actually big R. So I have, and this negative and negative cancels each other's out. So I'll have just K over H, and then plus R over 2 plus T infinity. is to be noted that, oh, this is correct, this is correct. But personally, I could also cancel this k out to make this job a little easier. So what I would actually prefer is, let's cancel this k out, and make it k divided by k on both, so this becomes 1, okay. So this is what we have left, and we can actually plug the numbers in for C2, for solve for C2. So we're given E gen is equal to, so T infinity, so let's start with C gen, so 2 times 10 to the 5 watt meter cube over 2, big R equals 5 mil, so 5 times 10 to the negative 3 meter, and then we got 1 over h, where h is 25 plus r, 5, 10 to the negative 3, 2, k is equal to 0.05 plus T infinity, which is equal to 10. This should give, so 2 cancels out, I think it should give 500, and then 0.04 plus this, to think get 0.05. If you do the math, I think you should give us a 55. So C2 is 55. And now we know that at t is equal to 0, so this is just 0 plus C2, where C2 is 55, so temperature is 55 Celsius degree.